Hello, and thank you for joining. We will start in a few minutes. And I think we can start now. Hello, and welcome to the webinar. Today, we will talk about features that we have inside SolidCAM that help us to program Swiss type and Milton machines. And I would like to start from discussing of programming challenges that we meet when we would like to program these type of machines. Especially when you have a machine shop with various types of these machines. There could be multi-channel advanced Milton machines, multitasking machines, and also Swiss type machines. We will talk about these machines also. And the first issue I would like to pay attention on is the machine architecture. Here I have a couple of slides showing different machine kinematics that you can easily meet today on a market. It looks like there is no limit of how machine can looks like and from what devices it can consist of. The construction of turrets and number of these turrets and channels is also differs and different producers today have different machines and we can choose whatever we like to have. And also a machine can have a very flexible structure. For example, as you can see on the slide, this is a Swiss type machine, and this is a short piece of instruction which is supplied together with machine. You may set up different attachments, and here you can see the description of these attachments all around. You can combine these attachments in different ways. You can even add additional attachment even after you got the machine to your floor, to your shop floor. That means we have a very various functions for the machine, and the working zone can also differ even if name of the model of the machine will be the same. You can have two machines with the same name of the model, but the construction or what you have inside working zone attachments may really differs. So the next challenge I would like to name is a variety of tool holders and attachments and any other devices that could be added to fix our cutting tool. On the Milton machines, we have two types of tools. It says tools which are rotating, so it's like a milling tool, and tools which are which have no rotation. So this is tools for turning operations. Here on this slide, you can see different holders, but all these holders could be supplied to a very common and well-known BMT rotary turret. So you can apply these holders, and the facility of machine will also be wider. And here you can see the holders for driving tools that could be aligned with different angles. I mean, these three tool holders we have even from catalog. This is pictures from a catalog. So you can manually set one part of the holder to the angle which you would like to have. And for the programmer and for the CAM system, that means that you need to describe the same holder. It will be good if you will have the same model. It will be good if you don't need to import again and again the holder with different angle. You need to have the only one holder, and you need to have a possibility to align it to the angle that you would like to have in a different setups, even inside the same CAM project or inside the different CAM projects. So this could be a problem. And this challenge that you can meet when you have a deal with multitasking advanced mill-turn machines. I'm sorry, and here you can see the short description. This is a piece of the documentation of Swiss type machine. So this machine model could be equipped with different attachments. And that means not only that we need only a 3D model, for example, to represent this inside the working area for machine simulation and so on. We also need to be very careful when we set up these attachments to the machine zone, because machine zone will differ, and you can see this detailed description inside the manual. And believe me, there is a whole chapter inside the documentation describing how it should be set, what limitations machine will got, and so on and so on. So it is quite a complex process. And also, together with different attachments, we will have recommendations about tool offsets. Tool offsets also will be differ. And I mean tool offsets which will be outputted to the G code. There will be different commands. Also, there will be some recommendations about outholder length of the tool, which is allowed it on this machine. So it is quite a complex process, complex and important. We need to consider it every time we have a deal with these machines. Okay, let's go to the next challenge that I would like to mention. It is I called it Special Approach to Program Structure. This comes mostly from Swiss type machines. And also inside the machine manual, you may find even a big chapter about how the program should be written. The structure, you can see the detailed description for each part of the program. And this is also critical for the Swiss type machines. But imagine situation when you have a ready program for a part and you have to transfer this technology to other machine with different program structure. And for example, different CNC, you may have this situation both for manual and CAM output, and this also could be a problem, could be a challenge when you have a deal with multi-channel machines. Okay, and here I have several videos from Swiss type machines, very nice. The central video was shared with Daniel. This is quite fresh fresh outputs that he had at one of the customers. In terms of operations, we may have different complexity. We may have meet the demands of the operations from 2.5D to 5-axis simultaneous. till turning operations, and lace and turning operations could be also quite complex. I'm talking about balance roughing and different axis combination, combining on the Swiss type machines. I would say it's much complex than on 5-axis milling machines, because you need to combine them. Also, you need to consider different channels. The central video shows us 3-channel machine, for example. So all this stuff should be considered, and you should have functions that will help you to handle with all variety of cutting operations that you would like to represent on your machine. Okay, the next challenge could be CNC programming modes. This is very important. I know that people from milling world, they may now have idea what is programming mode for mill turn machine. So we will consider this a little bit later. I will show an example, but that means that different geometrical, the same geometrical element could be the program for it could be outputted with different G-code modes, and the machine movements will differ. For example, this picture shows the output with 3 axes, X, Y, Z. So it is like a milling. But for example, this picture shows the output without y-axis, because it could be limited. We may even not have y-axis, but we have to machine these type of elements. And you will never meet this mode on the milling machine. It is only mill turn. And there are also several programming modes, and you should be careful with it. And you should have a functions that helps you to output it quickly and easily. Okay, the next challenge I would like to name is a multi-channel synchronization and organization of the process of the sequence of operations, and also axis combining modes. You should be very careful with this when you try to organize operation sequence on a multi-channel machine. Multi-channel synchronization and axis combining modes is a must for each Swiss type machine. And as you can see, this is also some pieces of documentation, and this is how the description can looks like. And this is just a piece, because each of these this is called access pattern, which each of access pattern also described in a very detail which axes are allowed, which are not, which one could be combined, which are not. And you may output the same operation, you may output in different modes. This is possible, and you need to have a flexible tool to manage with all these processes very easily, quickly, and you should be sure in the result. Okay, sorry. The next slide will be, we go into the end of the challenges, is a predictable operation setup and verification of the result that you got. Swiss type machine setup is a very important stage of programming process. You need to carefully follow instructions and track outside hole the length of the tools and other dimensional data. You can see this as a piece of documentation which shows us how the tools could be set up. One more problem is axis strokes that could give you limits error message after G-code will be run. So I had quite a common situation, and I've got demands from the customers. They wrote the G-code, it looks okay, verification was okay, but when they tried to run it on the machine, they got error messages. And it is good if you have these messages before you will run the machine and you're doing some verification on the CNC. Not all CNC has these verification functions. You may meet these errors after you will run the G-code. When you start cutting, you're doing something inside the working zone, and you're stuck with error message. So this is a situation that we should avoid, and we need a tool that will help us to avoid this. Okay, and the last one program challenge I would like to mention is easy change and output of the G code of the program and saving data. This is important issue also. It is we need to possibility to quickly and easily change operation order to add or delete operations from this order. For example, suppress because, for example, I don't want it now, but maybe it's not bad. I would like to have it in some other situation with the output. For example, I would like to change the tool, and for one tool, I will create the one type of operation. For other tool, I will create the second type of operation, but they could be run one by one, or I would like to suppress one because I don't have this tool now. So it should be flexible. And also, you should understand what's going on. You do not need to go too much deep, doing too much clicks inside software to find this information. Data storage is also critical. What if you will have to return to the current project in 3 months, half a year, or 1 year? Will you remember tools and cutting conditions you had at that times, tool setups, and other information? This is important. Okay, now we have the list of the programming challenges. I think there could be find more, but I choose this one as the most common and I would say critical. And yes, SolidCAM can handle all of this. We have a solution that meets programming challenges. And let me show you like an overview of this solution of the how we can handle this. And we will start from machine architecture. In this point, I would like to mention our very flexible tool, which is called Machine ID Editor application. We can cover all variety of machines with any complexity because this tool is very powerful and it let us build any construction that we need. It has proved and clean machine tree structure where I can take all necessary devices like stock table, tool table, bar feeder, part catcher, and even custom device. And from them, I can build machine that I need. Moreover, I can assign device properties, axis, limits, and CNC behavior. I can add channel information, axis patterns, and finally build a model for machine simulation. All I need in one application. So I think you from my previous slide about machine architecture as a challenge, you saw that they looked like a Lego. I can I can take from the machine supplier a machine with different devices. I can mix them and so on. We may not imagine what will be the day after tomorrow, what will appear on the market. But we have a very flexible tool which uses the same strategy of building whatever we need. All these logics is supported with the software. This is why we can support any machine that can appear in the future. Okay, let's go to the next slide. And this is it. And this is the challenge, which is called variety of tools. And for this challenge, we need to go to the software and we need to consider, we need to consider the toolkit, our new functionality and very flexible application. We had a series of webinars about this amazing tool. We have it like an overview and also even some tutorials how you can use it, how you can add different type of tools. I will give you just a quick overview of what we can do here. For sure, it is not all that we can get from this application, but I think it is very impressive, especially because we will consider it on this type of machine. This is very, very interesting machine. It is Tornaz machine. And as you can see, all these green attachments, they could be mixed whatever you like. So you can take the machine without attachments, and then you can order different kind of attachment. The variety of attachments is really huge, and you can mix it whatever you like. So this is a true Swiss type Lego. And this is how we can support it. You can see the structure itself. This is access available on the machine, and this is named as we have it on the machine. And each axis has the position. So this is the original name of the position which we have from Tornaz documentation. And on this position, different attachments could be set. Okay, I can change them. I can change the place of these attachments, for example, and I can do this easily inside Toolkit. I can save this configuration to a separate machine library, create a new one, whatever I would like to have. And with conjunction with post-processor, I will have the proper output depending on the setup of the tools that I have. So the post-processor working in the conjunction with Toolkit. This is important for the machine. And let me show a little bit more functions. I can't show you all. We have webinars about this tool, but I show you a little bit. So I can change the position. I can change the holder. Let me show it on this very nice holder. I really like it. This is a holder with 5 OD tools, but I don't need to create 5 tools here. I just have these positions inside holder itself. So I have a holder and I have different positions inside. And for example, if I would like to change the position of this holder, I don't need to transfer it one by one. I'm changing the position of this attachment, of all this attachment. And this is how it works on the machine itself. And this is a normal tree. We can have the attachment itself. We can change information about OD holder. We can change information about insert. This information comes from our common default library, but also I will show you later. For example, this tool is a 3D model which we got from the catalog, from the tools catalog. So we can handle with this also. As you can see here, we have several buttons to manage with each item. First, you should choose the item. Then you can choose the position of this item. You can change tool number for sure. By the way, tool numbers will differ, depends on what attachment is used and where this attachment is set on the machine inside the working zone. This also important. And here, for example, I can have a description of joint. The joint is the position inside the attachment itself. And also, if I go to profile, I have a cutting point here, and I can choose what cutting point could be used here. Okay, now let's check these attachments. I really like these attachments also because it is, as I say, double drill, but it has a milling tool, so it's like a double milling, double drill. It is driving attachment, and as you can see, it can work both for the main and for the sub spindle. By the way, as you can see, it's a machine preview window, and I can also check the position, how it can move, and if they have no gouges. Even before I will run machine simulation, I can check the position of the tools and if they are okay for this machine. So Now let's move to this attachment. I guess it is here. Yes, you can see I have, it is easily to find information about the attachment. I just click and I have graphical information inside machine preview window. So as easy as possible. And here I have a little bit different structure because I have a holders and I may change the position of this holder. I may change a position of this collet according the attachment, and also I can change the position of tool according the collet. All levels of management of all levels of operation and setup of tools as I may have on a real machine. So for example, we can go here and change the position. I don't know if it is visible now that I can move it. Okay, you can see this is air collet, and I can change its position. Okay, I can change, save, recalculate, and it will work. If I would like to change the position of the tool, I can go to the same. Okay, I can go to the same window here and to change the position of the tool also. Okay, I think a little bit luck because of the visualization. So it works. We have different joints and we can manage with it. Okay, it is here. I'm sorry. And now let me show you one more nice thing about these attachments. So here we have these blocks and they are completely separated. So I can take it off from the machine. I can set it on the machine and I can change it, replace them. And I like Toolkit doing this job for me. So for example, I have this nice attachment here. So it's for the face milling, I think, or maybe face drilling. And also this attachment is for radial milling. As you can see, the direction of the tools will differ. Okay, and for example, I would like to change the position of this holder with this one. I have a very nice context menu here, and I can choose the position which I would like to change like this. Okay, that's all. One click and configuration was changed. And we can do the same with all available attachments. So we can talk quite a long about these nice tools, but we need to move further, I think. Just one more. Let me show you. I also really like this toning tool. Okay, this one. So just to show you that we can import it. As you can see, this is the item which was imported from the catalog, from the tool catalog, and I can import both the holder if it fits to this machine. I can import insert, and I can assign a cutting point. And we have tutorials about these functions. And also we have this very nice picture to check attachments one by one, and to even do some measurements here if needed. As you can see, there is a black line which shows what I tried to measure, and there is information. So it is very nice and flexible tool, and we are making it better and better in all new versions. Currently, we can support a wide range of functions from the holders, from the tools, and for milling, for turning. So it is very nice, and it helps you to avoid this challenge, to have a deal with this challenge and to manage it. Okay, let me go back to presentation. And the next item is a special programming approach. This is how I call it. And this is about how we can manage with demands of the G code. It comes from different sources. First of all, we have a description inside postprocessor itself. We have several different functions, how we should output our program. I would say for Swiss type machines, for the same model, we may have different types of outputs. It depends on the situation for sure, but we have a possibility having the only one CAM project, CAM part, no need to change something inside, but we can, with just one parameter, have a different types of output. For example, Mitsubishi and also Fanuc supports one file as a G code, even if it has several channels. Or some people prefer to have several files when they output this. We can also add different variables as a machine options. As you can see, smart markers here. We can add all information your machine needs to do the output. Part ejection, different cycles, and so on and so on. All this stuff will be supported both from postprocessor VMID file, GPP file, also from project itself, and from MCO operations. This is a very nice and flexible tool which helps us to have a deal with quite complex operations and codes. Okay, now I would like to show you a very nice video from our German department that shows how we can combine milling, different milling operations with turning operations on one machine. So we can join all this functionality. We can have a nice postprocessor which describes the machine structure that you need, absolutely the same as you have on your machine. We can describe all attachments as they are, all tools as they are. We can even import them from the tools catalog, and we can apply all this stuff for the cutting operations from 2.5D, because we have a wide range of modules. If you need 2.5D only, then you can have only it. If you need 5-axis simultaneous, you can have it. iMachining, 3D operations, machining of surfaces, HSS, roughing, finishing, and also different turning operations. Whatever you like, you may have it separate, or you can mix it depending on the complexity of the geometry going to cut. Okay, and also we have several very nice videos that showing how we can program it, and there are very nice tutorials for all modules, and you can find information how you handle it. You can take, for example, a demo version to try. So everything that shows that we can support this easily, and very powerful tools that are available for all kind of operations. Okay, now a short example about CNC programming modes. This is very common situation that may comes not only for Swiss type machines, I would say for all mill turn machines. Here you can see two very simple holes on a face. And if you have a mill-turn machine, you always have a question how I should output the G code and how machine should move if I would like to cut these holes. Believe me, there are several modes to output this. You may cut it as normal as it would be milling, so X, Y, Z axis, and for example your C axis will not move, only your holder and tool will move around the part. So this is like a normal, and we have a part, a area inside the technology, as you can see, it called motion control, and I do not change something there. But if I would like to output the same operation, I do not need to recalculate it, to add a new, to reduce geometry or whatever. All I need is just click 4-axis. That's all. That's all I need. So 4-axis, and it will output me it with C-axis. Just one click and you will have the absolutely different result. And for machine, it is critical because you may have limitations with Y-axis, and you may need C-axis to be implemented. And believe me, for some systems, it takes time to have a deal with this. But in SolidCAM, it comes just with one click. Okay, now we should consider multi-channel synchronization and organization of the process. This is one more very nice tool that we have inside. When you finished with your operations, you add them all. Also, you add the cutoff if you would like to have for example, cutting of two parts for main and for sub spindles. You would like to have several channels parallel. You need to add a cutoff operation. You need to add a part ejection, and your cycle will be full. And after that, you should assign the weight marks, and you should assign access patterns if your machine support it. We have it in automatic mode, and also you can manage it whatever you like. You can change order, you can put them as you need, from one side, from other side. And operations with part clamped in both spindles. Here you can see the diagram where on the left side you have a main spindle. On the right side we can see a back spindle, and here we can see the tool, and we can work together with this tool when the bar stock, our stock, is moved with Z-axis, and Z2 axis is followed with this axis. So it is clamped into spindles, and we can do cutting. We can even change tool without reclamping. For example, I can do turning, I can do threading, cutting, and cut off one by one together in this mode. So this is what we call synchronous control, and each Swiss type machine has this mode. How we can manage it in SolidCAM? I can create a cutoff operation as normal, and then I don't need to recalculate or recreate this operation. I need just to add an MCO cycle which says that, okay, now I'm going to cut it into spindles. I will clamp it with the back spindle, and I will turn on synchronization mode. Currently, you will not find this type of representation of customer interface in our post processors. We will cover this on the cycles. So you don't need to care about what to choose here. You just choose the cycle and that's all. It will do everything what you need, and we have these cycles under technology. So this is one more very important and very useful functions that we have. But we have this inside post processor, and it is done easily. It is described completely what is allowed, what is not, and you will have messages from the system if something goes wrong. The one more, I would say, more complex combining mode, which is called mixed control. It is also called axis recomposition or composite control. This is on the left side. This is example from machine documentation. We can have a basic controlled axis. This is like a normal, okay, for this machine. And we have mixed control. And some of accesses which previously were on the second channel, for example, could be managed in first channel. Of course, there should be some commands before which says to the machine, okay, now I can manage with these 3 axes from the first channel. So this is how it works on the machine, but for sure we need some additional functions inside the CAM software to support this, and we have it. We also have it, oops, sorry. Okay, we have it from the software, also from MCO cycles, and we can see these inside synchronization table. We can choose how we're going to manage it. For example, currently I will program turret with Z1 axis. That means that only the bar will move and turret will not move. It will. This is a Swiss type machine with both turret and a linear turret, as we call it. This is a piece of turret, and I can use turret with Z1, so turret will not move in Z, only bar will move. Or I would like to have it like a normal lace machine, so I will have my bar. It will not move, and the turret will move in Z-axis. So this is cross-axis control, okay, and I can describe different submachines to represent this this mode for the software, and I will have the information about this process inside synchronization table, because as you can see, it names axes that will be active for this operation. Okay, and the final mode I would like to describe is the balance or pinch cut. It can be both for milling and for turning. On the left side, you can see it for turning. We also call it balance turning, balance rough operation, when we have two cutters working together and they divide a drive unit, as we call it, because both of these cutters are working with the same drive unit, with the same spindle. So spindle rotation is the same for these cutters. And on the right side, we can see, which is called pinch milling. We have separate rotation of the tools. They have their own drive units, but they divide stock, I would say. The stock is the same for these tools. This is also very interesting functions on a Swiss type machines, and we do support them. For turning operation, we even have a separate operation, which is called balance rough operation. We can convert normal turning operation to balance rough. We have a button for this. And as you can see on the from the interface side, we have a clear description of what should be filled in for this operation from the customer side. There are several modes inside this rough turning. It depends of what you would like to get from machine. And also, yes, by the way, this is a piece of synchronization table. Again, we have information inside table about this operation. It says that this operation will be on the both channels. This means that we divide the drive unit. As I said, the drive unit comes from the main spindle. And also we have a description of axis here, because these tools in this example will also have the same z-axis. Okay, so for example, turret will not apply z2 axis. Okay, so both of these attachments will work as for sliding head machine. And for sure, we support pinch milling. In this case, you will need to create a separate milling operations, and then you need to synchronize them on the synchronization table. As you can see, for this machine, for this example, these two operations, they have the same Z and C axis, and we have this information inside synchronization table. Okay, and now information about predictable operation setup and verification. It comes from different sources, and the main source is machine preview. I showed it today. Before you will start to add operation to the COM tree, you need to fill in information to machine setup dialog box. Here you should describe if you have some fixtures, for example, we have jaws here, and how your stock and target is positioned according this fixture, where you will put your coordinate system to calculate, and you need to describe this process for all tool tables you have on the machine. Here, for example, we have 2 tool tables. This is information you should add before you will start program, and you can check how it looks inside the machine zone with a machine preview. This example we also saw today. The next step is tool setup. We can arrange all information you need, and as I said, post-processor will take information from Toolkit and will output the data you need. And also we have machine preview when we have a deal with machine control operations. This is example of operation of catching the stock with sub-spindle from main spindle. So this is preparation to cut off when the stock is clamped into spindles. We need to move the back spindle towards the part, and we need to know for sure where it will clamp our stock, because all the system will rotate, synchronized, and so on. And we can check this with machine preview. All these numbers will be shown inside machine preview window. And the final verification comes from machine simulation. Okay, we can take a lot of information here from this part of the software, and we can get error messages, all information, if it is okay, if it is not, what should be checked and rebuilt if necessary. Okay, and the final slide for today is about change, output, and saving data. I didn't mention, but I believe you all know that SolidCAM is a CAD integrated system. That means that all CAD data is also saved inside project. You have a stock, you have a part, you have all fixtures and all CAD information, for example, sketch, planes, whatever you build inside the project. You have everything saved, and you can open it in, for example, here, and you can, for example, convert it, you can export it, you can use it in other projects and so on. It is very useful. Also, for sure, we can store information about tools separately. I didn't say it also, but we can open Toolkit separately from SolidCAM, okay? So you may not open SolidCAM, but you can open Toolkit, and you can take all information from this application. You can even add a cost of the tools and the name of the supplier, for example. and you have everything inside. You do not need any other storage for this data. And you have the storage, for example, like a setup for machine, and you can have the storage like a part for this particular part, for this particular project. For example, you used this set of tools and holders and so on. All this information could be stored and changed and converted very easily. For sure, we can easily change, add, remove, swap operations in a part tree. This is now our normal functions. We can suppress, we can copy, we can move this operation, drag and drop. I didn't also mention our templates functionality, but this helps us to work with the project very gives us flexibility. Okay. We can also store and apply channel synchronization data. As you can see here, we have export button. If you have a number of operations and the sequence is quite complex, and for example, you're not sure what kind of synchronization you would like to apply, if it will be okay or if it will be not, you may create several sets of synchronization and you can save it. You can save it, you can analyze it, you can try, and you can store it together with project. You do not need to do it from scratch, for example, to create it. For example, you can forget in a month or 3 months, you can forget how you did it previously, but you can save different versions. For example, which one will be working and tested, and other one could be, for example, planned versions that you would like to try, but you hadn't time and so on. So this is also a very nice function that we have inside the software. Okay, I think that's all. Thank you for listening. Thank you for being here with us on this webinar. I hope this information was useful, and please take care and be with us also with the summit, which is comes and we're going to provide on 11th of May. Thank you very much.